stability of the metastable peak. Let's move on to the instrumentation. So the most important parts of any mass spectrophotometer are the ionization chamber and the analyzer. In ionization, there are many methods of ionization. Okay, there are far many methods of ionization. The most important are electron ionization, chemical ionization, desorption ionization. It is many a times also called as matrix assisted laser desorption ionization. Then there is something called as fast atomic bombardment ionization. Then in atmospheric pressure ionization, you have electrospray ionization, you have atmospheric pressure chemical ionization, and then you have atmospheric pressure photoionization. See why it is important to note that this is atmospheric pressure. All these four they take place in vacuum. They take place in vacuum. But these three methods they are carried out at normal, that is atmospheric pressure. So why these may be important? If you are using these techniques, you can couple mass spectrometry with your chromatographic technique, that is your hyphenated technique, because in chromatography the element that is coming out of the column, it does not have any pressure. Okay, so you can couple mass spectrometer with chromatography. So that was regarding ionization methods. Then you have analyzers. The important are quadruple, ion trap, time of flight. If time permits, we will study few more analyzers also. So this is the block diagram. First you have the sample. Sample is injected into inlet system. This inlet system lets sample to be transferred into ion source via with some specific rate. Okay, so inlet system का काम क्या है? It will adjust the rate of introduction of the sample into the ion source. Then once ions are produced, they are transferred to the mass analyzer. Mass analyzer separates the ions based on their m by z value or mass value. Then those separated ions reaches to the detector. The detector only detects the ion and pass this information in the form of electrical signal to the signal processor. This signal processor interprets and gives the graph from readout system. Now, inlet system, ion source, mass analyzer and detector, all of them they operate at very low pressure, and for applying that low pressure vacuum system is used. Okay, now one part is that this mass analyzer is also connected to signal processor. Okay, this is also connected to signal processor. So in the mass analyzer, what is the electrical field applied or what is the magnetic field is applied is relayed to the signal processor. Only then it may interpret the electrical signal given by the detector. This is another representation of classic. So ionization methods, let's start with the basics of ionization methods. See, the starting point for mass spectrometric analysis is the formation of gaseous analyte ions. Ion sources fall into two major categories: gas phase sources and desorption sources. So as you are expecting, in the gas phase you require sample to be present in the gas form. In desorption sources you require your sample to be embedded into a solid or a liquid support. So in the gaseous source, the sample is first vaporized and then ionized. In the desorption sources, the sample in a solid or a liquid state is converted directly to gaseous ions. तो पहले उनको molecules, isolated molecules में convert नहीं करते. You have them in solid or liquid state, and from that directly they are converted to ions. This is classification of sources, ion sources in mass spectrometry. There is another type of classification in mass spectrometry. Ion sources are also classified being hard sources and soft sources. When you say hard source, that obviously means the ionization will occur at large extent. There will be higher energy involved in the ionization. In the soft sources, the energy used will be smaller. So if energy given is higher, there will be more fragmentation. If the energy is lesser, there will be less fragmentation. There is the difference between hard source and soft source. There is the same molecule being analyzed. You can see the difference is huge. Okay, the molecular ion peak is almost negligible over here in the hard source, where in the soft sources the molecular ion peak does exist. The first type of ionization source is electron impact sources. So as you must have expected, you are going to use high energy electrons that are going to impact on the molecules, that is your sample, which is already in the gaseous state. The sample is brought to a temperature high enough to produce molecular vapor, which is then ionized by bombarding the high energy electrons, resulting molecules with a beam of energetic electrons. So molecule bombarded with electron, you get M plus radical and two electrons. So M plus radical is your molecular ion. Relaxation then usually takes place by extensive fragmentation, giving giving a large number of positive ions of various masses that are less than that of the molecular ion. These lower mass ions are called as daughter ions. Since the ionization extensive, this is a hard source of ionization. This fragmentation we have already seen, so I will not go in this again. What are the advantages and disadvantages of electron impact sources? Electron impact sources are convenient to use because of good sensitivities. The extensive fragmentation and consequent large number of peak also is also as an advantage, because it often makes unambiguous identification of analytes. So exactly what is present, you may get that information. This fragmentation can also be a disadvantage. However, it results in disappearance of molecular ion peak that we have seen in the example. Another limitation of the electron impact source is the need of volatilize the sample, which may result in thermal degradation of some analytes before ionization itself can occur. Electron impact sources are only applicable to analytes having higher molecular weights, analytes having molecular weights smaller than 10 raised to 3 Daltons. What if we use electron impact sources on high molecular weight compounds? Largely they will get unaffected because of their size. Okay, then next after electron impact is chemical ionization sources. In chemical ionization sources, gaseous atoms of the sample are ionized by collision with ions produced by electron bombardment of an excess of a reagent gas. So you are going to add a reagent gas along with your sample. A gaseous reagent is introduced into the ionization region in an amount such that the concentration ratio of the reagent is 10 is to 3 to 10 is to 4. In simple terms, when there is one molecule of the analyte is present, there are 10 raised to 3 1000 molecules of the reagent gas present. So reagent gas is in huge excess. We want to use in excess. How much is the excess? We are using it 1000 times or even 10,000 times of the concentration of the analyte. Because of its large concentration difference, the electron beam reacts nearly exclusively with the reagent molecules. Because they are present in large number, the electron that are getting impacted will first affect this reagent gas. One of the most common reagent is methane gas, which reacts with high energy electron to give several ions such as CH4 plus, CH3 plus, CH2 plus. Now, these ions react rapidly with additional methane molecules such as, see, you can see this first ion reacting with another methane molecule to give you CH5 plus and 3, then CH3 plus 4, C2H5 plus and H2. So what we mean to say is we are getting huge number of positively charged ions because of this. Now, because we have variety of ions that are reacting with the molecule now, we will get variety of the ions from molecule itself, from analyte itself. Collision between sample molecule MH and CH5 plus or C2H5 plus are highly reactive and involve proton or hydride transfer. Some examples are over here. Originally you have MH, but now you got MH2 plus and CH4. Originally you have MH, now you have got again MH2 plus and C2H4. In this case, the molecule itself is losing the hydrogen along with its electron to C2H5 plus, and neutral molecule is the product. So all of these which I am encircling are going to give you one peak in the mass spectrophotometer. See, proton transfer reaction gives M plus 1 ion, whereas the hydride transfer produces an ion with a mass 1 less than that of the analyte, or the M minus 1 ion. With some compounds, an M plus 29 peak is also produced when this entire part C2H5 plus is getting added to the molecule. Now, all these techniques, these two techniques, they were carried out in what we have studied so far: electron ionization, chemical ionization. These two are remaining. They are related to matrix. Okay, both of them are related to matrix system. Let us start with liquid techniques, also atmospheric ionization techniques. See, depending on the solvent composition, molecular properties, we can use one of these techniques: atmospheric pressure ionization, electrospray ionization, atmospheric pressure, chemical ionization. The first is atmospheric pressure photoionization. So from here, the sample is introduced. It may be the HPLC inlet, that is यहाँ पे column होगा HPLC का, and from the column the outlet will be provided to the mass spectrometer. Here it will be the flow adjustment unit. Okay, so that solution will enter here. It will be first mixed with nebulizing gas. Okay, nebulizing gas. So it will be mixed with the nebulizing gas. Then there will be heating part in this region. So when it is heated, what will happen? The solvent of the HPLC effluent will get evaporated. At the same time, nebulizing gas will produce a spray. So you will first get larger droplets. The size of the droplets will go on reducing. Ultimately, you will have molecules suspended. Those molecules will be bombarded by UV light. UV light will bring about the ionization, and those ions will be attracted by this negatively charged capillaries through which the ions will travel. Now, there may be introduction of drying gas, whereby the solvent from HPLC solvent will get dried. Okay, so the energy of the can say photoionization should be selected properly depending on the analyte molecule. Then next is atmospheric pressure chemical ionization. See, it involves rapidly vaporize the entire liquid flow. Whatever is coming from the HPLC column, everything is vaporized very rapidly. Ionize solvent molecules in corona discharge. We will see what corona discharge is. Chemical ionization process ionizes the sample molecules. There is a positive mode and there is negative mode. In positive mode, proton transfer or charge exchange is taking place. In negative mode, proton abstraction or hydride transfer or electron capture that takes place. Applications of APCI. APCI works well for small molecules that are moderately polar or even non-polar. APCI works well with samples that contains heteroatoms. We need to avoid samples that are typically charged in solutions, which get dissociated in the solutions. That will be difficult to handle. Similarly, thermally unstable or photosensitive samples cannot be used either. This is the reactions involved. Okay, sometimes dopant may be added. So dopant is a molecule which will first absorb the photons, and it will transfer its energy uh, to the analyte, and the analyte then will get ionized. See, you can see these reaction. Okay, dopant got ionized, reacted with molecule. There is hydrogen transfer, and you got M plus H, M plus 1. The other possibility is dopant reacting with molecule and producing the radical ion from the molecule, analyte molecule. This was the chemical ionization that we were talking about. This is the corona discharge. In the corona discharge, basically there is a metal wire, and that metal wire has a very high voltage on it. So at the end, from the end, you can see the corona discharge coming out. So it is basically the high energy voltage that is giving out at corona discharge. The other concepts remain same, that we have to heat it to produce smaller and smaller droplets, and the ionization is brought about by corona discharge. Okay, we will stop here till APCI. I'm going to share these slides on Google Classroom. So till APCI we have covered everything. Okay, so it will be there in your exam. Let us see how much we can cover tomorrow.